been doing thus far. The only thing is it doesn't have complex numbers, which is what we'll do next, right after this problem. But the complex numbers aren't as crazy. So here they give you a function, and they ask you to find the zeros. Again, to find the zeros, that means it's asking you where does it cross the x-axis, right? These are the zeros. And the question is, and that's the x-intercept. So where does it cross the x-axis? And where it crosses the x-axis, that's when y is equal to 0. So wherever a function crosses the x-axis, y is equal to 0. So we want to know where is it? So the problem with this is, does it give us an initial 0? No, right? So the problem with this problem is that no zeros are given to us. If a 0 was given to us, we could run with it. So since no zeros are given to us, what must we do? Find it. And how do we find it? What theorem are we going to use?
Rational zero.
Right. We're going to use the rational zero theorem. So the rational zero theorem will give you all the possible zeros, right? So we're going to use the first, we're going to, since no 0 was given, and that's when we feel sad, oh man, I got to work. So since no 0 was given, we use the rational zero theorem, I'll call it the RZT, the rational zero theorem, to find possible zeros. Doesn't mean that they are it, but they're possible ones. So here, the rational zero theorem says that we're going to look at, what are we going to look at? Right, the factors of the constant divided by the factors of what?
Leading coefficient.
Factors of the leading coefficient. Okay. So what are the factors of the constant in this problem?
Negative.
Okay. So what is the constant, first of all?
1 and 3.
So the constant is 3, right? So the factors of 3 are plus and minus 1 and plus and minus 3. Great. Now, what is the leading coefficient in this problem? 2. And how do we know it's 2? Right, because it's attached to the variable with the highest exponent. So the variable with the highest exponent is called the leading term, and the coefficient is the one that's attached to it, that's multiplied with it. So 2 is the leading coefficient, so the factors of the leading coefficient are plus or minus 1 and plus or minus 2. Great. So now we find all combinations of this. So the combinations of this are going to be what or what? Plus or minus 1, because 1 divided by 1 is 1. What else? Plus or minus 1 over 2. What else? 3 over 1, which is just 3. Great. And last but not least, 3 over 2. So these are the possible rational zeros. How many of them are there? 8, right? So these are the possible ones. So possible rational zeros. Doesn't mean that they are all it, but it might, one of them might be it. So now that we know that, we are going to check. We are going to find out which of the above, which of the above is or are an actual zero. So which one really is it? Because these are just possibilities. We want to know which one is the actual one. So guess what theorem I'm going to use to find that out? The remainder theorem. So remember, if you plug any of these into the function, if you get a 0, the remainder theorem says that 0 means it's the remainder. And if it's the remainder, that means then yes, if the remainder is 0, then yes, it is an actual 0. So find out which of the above is an actual 0. So we're going to plug it in. So we're going to plug into g of x to find out which will be g of x will equal to 0. Okay? And this is going to be using the remainder theorem. The remainder theorem right there. So we learned the remainder theorem at the beginning of class. So here we're going to plug in g of 1 g of negative 1, g of 1/2, g of negative 1/2, g of 3, g of negative 3, g of 3/2, and g of negative 3/2. Holy smokers, that's a lot. If we're lucky, we find the right one on the first try, right? So there is a fast and easy way of plugging this into your calculator, and I liked what Nam actually showed us on Tuesday, where you could cut and paste it, right? You could cut and paste this over and over again on your graphing calculator, and all you do is you plug in a new number. There's multiple ways of doing this fast and quickly. Here, we're going to go into the cut and paste version. Again, there's many different ways of doing this. I'm just going to do it this one way. So 2x cubed. So which one do you guys want me to plug in first? What do you want to try out? Okay, let's plug in 1. So I'm going to plug in 1 in here. And actually, do we really need to plug in 1? We could do this in our head, right? If we plug 1 in here, everything stays the same. What's 2 plus 7? 9 plus 2? 11 minus 3? 8. Does that give me a 0? No. So by the remainder theorem, it does not give me a 0, so therefore it is not a 0. Okay, if we do negative 1 in here, right? So this becomes a negative 2 plus 7. What's negative 2 plus 7? 5 minus 2. 5 minus 2 is 3. What's 3 minus 3? 0. Put down. So actually we didn't have to use our calculator for this. So negative 1 does give me this. Winner, winner, chicken dinner. I could stop there. I don't have to check with all of them, right? I could do with all of them, but I don't have to. I just want to show you guys on the calculator though, just reiterating what we did in class on Tuesday of how you plug things in quickly. So say I wanted to plug in 3, right? Say I wanted to plug in 3. I go 2 times 3 to the cube power plus 7 to 3 squared plus 2 times 3 minus 3. I get 120. So does 3 work? No. So 3 does not work, right? So now I want to plug in, say, negative 3. Instead of typing out the whole thing again, what your classmate, what Nam told us is you can cut and paste, which I did not know that until Tuesday. You press enter, and it cut and paste the top onto the bottom. And you can go in, and you can change it. So instead of 3, I'm going to put a negative 3. So to put a negative 3, I have to put second insert, because I want to insert a negative in here. Make sure you put the negative, not the subtract sign. You go here. Instead of putting a 3, I'm going to put second insert, because I want to insert a negative number. And then here, I'm going to put second insert, and I put a negative again. Press enter. Oh my gosh, it gave me 0. Right? So we know that this is also 0 as well. All I needed to do was find 1. So I could have just stopped there. We could try it for all of them. That takes a lot of time. I'm just going to run with just one of them. So suppose I didn't know that g negative 3 is actually an answer too. So I'm going to just run with one of them, the one that I know, which is g of negative 1. Now that we know that negative 1 is a 0, so now we know negative 1, x equals to negative 1 is a 0. So we know in this graph it crosses the x-axis at negative 1. So now that I know that, we're going to do what we just did in the previous problems, which is I'm going to rewrite this as, how do I write negative 1 in its factored form? Using the factor theorem? X plus 1. Right? So using the factor theorem now, you can write this as a factor as x plus 1. Well, x plus 1 times something, right? How do I find out what the something is? I use, what do I need to do? Use what? Synthetic division. So we need to use synthetic division to find out x plus 1 times what will give me this one. Right, so again, back to the beginning what we did. So now I'm going to use synthetic division to find out what goes in this box here. Right? Because I want to find x plus 1 times something will give me this. So using synthetic division, back to the other problem that we did earlier, we're gonna divide this by the zero of this, right? Which is -1. What would I write if I did synthetic division? What are the coefficients?
2,
2, 7,
2,
2,
-3.
and -3. Okay, synthetic division. And I'm dividing it by what number?
-1.
-1, the zero, right? The zero here. So, let's go ahead and solve this quickly. We drop this, we get
2,
2, multiply,
-2.
add, multiply, add,
-3.
multiply,
0.
0. And are we surprised it's a 0?
No.
No, it better be a 0, right? It better be a 0 because we're claiming that -1 is a factor, is a 0, right? So therefore the remainder should be a 0. Great, so here, what variables do I put here? 2 what? 2x squared plus 5x minus 3. So this is the quotient. That quotient goes right here, right? We use synthetic division to find out what the quotient is. So, right there, so this problem is like so big that I need like 2 boards, right? So I hope when you guys are doing your homework, you guys have plenty of paper for this, right? So here, this is 2x squared plus 5x minus 3, right? So now I have this times this. Whew! Am I done? No. I need to factor this. I need to write this out as factors so that I can find all zeros. Factor. Can I factor this? I see you guys say yes. If we can't factor it, what must we do? Quadratic formula. But if we could factor it, then we're happy, right? So using x box to factor this, what 2 numbers multiplies to give me 2x squared? 2x and x. What 2 numbers multiplies to give me 3? 1 and 3. One of them has to be a negative, right? Because this is a negative. So I'm going to do x box, cross multiply. What do I get when I cross multiply? 6x and 1x. Can I add or subtract this to give me 5x? Yes, I can subtract. Where do I need my negative? And the negative x. And therefore I will get 5x and then I get a winner chicken dinner number. So the negative, where do I put the negative? The -1, right? So x times -1 will give me -x. So again, this is factoring. If you guys are still fuzzy with factoring, please make sure you visit the Math Success Center or go get tutoring with Andrew, right? So now I'm going to rewrite this now as x plus 1 times, how do I write this out? 2x minus 1 times x plus 3. Fully factored. Whew! Right? And if you guys remember in the beginning of class, I said the whole point of this section is to find the zeros, right? We're getting closer and closer. Once you have it all in factored form, you're going to use the ZPP, yeah, you know me, the zero product property to solve for it. So now we're going to set this equation equal to 0, and now we're going to use the ZPP. The zero product property. So we're using lots of stuff, knowledge, right, to solve this. So we use a ZPP, set which one equal to 0. So I can now solve for my x. What is x equal to? -1, which we knew that from that. What is x equal to?
1/2.
Right, x is equal to 1/2. What is this equal to?
-3.
X equals to -3, which we actually found out earlier in the beginning when Nam plugged in a -3. And notice 1/2 is also in one of the possibilities as well. Okay. So here we have 3 answers. Whew, I'm tired.
That's all right.
That's it. And then, so I just want to say, welcome to college algebra. Look at how far you guys have gotten since week 1 of this class. Week 1 of this class, what were we working on? Adding, subtracting, multiplying, and dividing integers. We're learning how to add fractions. We're learning how to combine like terms. We're learning how to solve equations. And look how far you guys have gotten. You guys know how to solve quadratics. You know how to do X box, right? Now you're learning all these different theorems. You're learning synthetic division. You're learning all these different things. You learn the zero product property, and it all comes back to this, right? And then you learn how to solve linear equations. So you guys have gotten really, really far in 9 weeks. So you guys should be proud of yourself for getting to this point. So I want to warn you guys though, not all the time can you factor it. If you can't factor it, you have to use the quadratic formula, which you will see. Thank you.